When you open DNA2Face in 3D and load the shape model and the gene data, you get these two screens. This is the viewer screen that shows the face. It's a 3D object. At any point, if you want to export it, you can save here, push the save button, and export it as an OBJ file, which is a standard 3D file. You also see over here the main window that has tabs at the top: SNPs and ancestry, or sex and ancestry, SNPs, and then the shape space. The shape space shows the 44 PCs, 44 principal components that define this face. Here, since this is the consensus face, each of the values of those 44 PCs is equal to the mean value, hence the definition of the consensus. We can alter any of these values by placing a number in and pressing enter, and you see the effect of that. So here it shows on the bar chart here too, the histogram of columns, the value of that PC. All the others are 0. There's a consensus face. I made the first PC equal to 4. Affects the sex appearance of the face. Okay, you can always reset to go back to the consensus face. Push the reset button. So you can see how we push sex, click on sex here, we're seeing the effect of sex, and illustrated at the same time are the PC values and how those are changing. This is a more masculine face on the more negative side, and the PC values are changing. So a lot of the lower PCs are affected by sex, not all of them, and some of the upper PCs too. So again, reset. Now I'm going to pick ancestry and slide ancestry across. We're seeing, as you move to the right, a more African face. As you move to the left, a more European face. And the which PCs are changing in response to that are illustrated. Those are the PC values for that face. We can also click set, and then so we have a slightly more African face, and now I'm pushing sex. It'll make it slightly more African male, slightly more African, more female face. So you can change these faces in a lot of ways. You can also, let's see, reset, visualize the effect of individual SNPs. So I picked the first SNP, and we still have the slightly more African female face, and these are the effects of the one morph and the other morph. And some of the face shape change parameters are also on here: the curvature, the area ratio, and the normal displacement. Let me just show one of those. So this is the normal displacement value for that particular face. I've modeled some ancestry and sex effect, some of this first SNP effect, and those are the differences. This is where the red parts are the parts of the face that are projecting more compared to the consensus face, and the blue parts are the parts that are in more compared to the consensus face. So I also want to show you how you can load a particular face. Here is my face loaded into the model. I'm going to go back for a moment to the shape model. So there's my face, and these are my PC scores illustrated here in the histogram. Here are the values for those PC scores. So you could go through and enter each of these values one at a time, but the Excel spreadsheet that we imported is just a list of those values. And then here are the SNPs. So you have the SNP scores for that face too. So these are the RIP-G estimates of that face, and these could be compared with the genotype of that person. We can also do things like alter the sex and ancestry of that face. So I'm going to change my sex, make myself a bit more feminine here, and then move the slider in this way, make myself a bit more masculine. I can go back to where I was the beginning, and also alter ancestry to make myself more African. And it's interesting because you can see some of the defining characteristics regardless of whether made more African or more European. When you reach a boundary here, like you have on this side, because I was already more European looking, you can go pick a higher number from this, and that'll give you more space. So exaggerate my Europeanness. Also gives me more space on the African side. So those are just a few of the things you can do with the DNA2FACE in 3D software that we released with the recent PLOS Genetics paper.